Hi everyone, welcome back to the Technicide channel. Now in this video, we'll be looking at transposition as a balancing act. Yes, that's what it pretty much is. See the seesaw here? That's what I'm using to help us to understand that transposition really is a balancing act. Whatever is on one side must be equal to what is on the other side. So come with me and we'll solve some problems. Now, I've given 6 examples in this video, so use the description or the navigation bar to see the chapters I've created so that you can easily find the examples. So let's zoom in on our seesaw. Notice that it is able to swing from both sides, but then once both sides are equal, you will have your seesaw being leveled because both sides are equal, of course. So let's get to a very basic question. Now, in this case, you're seeing 2 plus 2 plus 2 on the left side of the seesaw, and you are also seeing 6 on the right side. Now, the 2 plus 2 plus 2 is equal to 6. And so we'd say in this case, both sides are equal, wouldn't we? Yes, we would. Now, if we were to just tip the seesaw a little bit, it would rock, of course, but it would go back to being balanced. So we are considering that in mind. Now, let's look at another example. If I had this, different numbers, 1 plus 4 plus 1, is that equal to 6? It sure is. 4 plus 1 is 5, plus another 1 is 6. And of course, on the other side, the number 6 is there. Now, please do not get technical thinking, oh, this has 3 things and that has 1. We're looking at the value. So 1 plus 4 plus 1 is equal to 6. So let's look at another one. Now we're going to tip the balance again and see, we did it to the left side this time. Notice it balanced back simply because both the values on both sides of the seesaw are equal. Going to another one. By the time we're done with this, you should be able to fully be able to transpose any equation. So let's look at this though. 6 on the left side and 1 plus 3 on the right side. Are those two values equal on both sides? They certainly are not. 1 plus 3 is equal to 4. So the right side is actually equal to 4, whereas the left side is equal to 6. Therefore, it being a seesaw, you naturally know that the heavier side is going to tilt the seesaw. And so in this case, we could not say this is an equation because the left side is not equal to the right side. Think you follow so far? Okay, let's continue looking at some other examples. So now we're going to look at a question that you need to solve. So we have x plus 6 is equal to 18. And we here solve for x. So now we're going to just put these on our bar, and we have x plus 6 on the left side, and then we have our 18 on the right side. So this is an equation. So consider in the middle here as the equal. All right, so let me actually put an equal sign here. So consider the middle, which we would know also to be a pivot. Let's look at that as where our equal sign is. So we have x plus 6 is equal to 18. Then we also look at the lower left corner where we see subject of equation. What is the subject of the equation? It's the variable we're solving for. So you'll hear me from time to time mention the subject of the equation. The subject is what we are solving for. So in this case, the question says solve for x. So what should be the subject of our equation? Yes, you got it. If you said x, excellent. So they want us to make the subject of the equation x. Now here is what's going to happen. We have on the left side x plus 6. We have on the right side 18. Now 18 is by itself and it's fine, it's good. But we have to focus on the left side now because x is not by itself. X is not yet the subject of the equation. So we have x plus 6. And according to the equation, we don't know what x is, but we know that x, whatever x is, that value plus 6 gives you 18. Now, remember also we said that both sides of the equation have to be equal. So currently, the equation is equal. Remember, if we do anything to one side, we must do it to the other. So, what could we do to the left side? We have a positive 6 there. Is there anything you can think of that we could do to cancel the 6, to get rid of 6? Think about it. Anything? All right. So let's try this. How about we subtract 6 because currently 6 is being added to x. So if we have plus 6 minus 6, if you have 6 and you minus 6, what would you end up having? You would end up having 0, true? Yes. You would end up having 0. So that the left side would have been x plus 0. Yes, it would be. So now remember, originally, the left side of the equation was balanced. And so, whatever we do to the left side, we must do it to the right side to maintain balance. Because guess what? If we don't do it to the right side, this is what's going to happen. The equation is not balanced, or seesaw is not balanced at all. So how do we fix this? Let's look at it. So we're back to normal. We add our negative 6. If we do this, subtract 6 from this end, wow, look at that. Our seesaw is now balanced. Then no, because 6 minus 6 would cancel each other. That's what we say when it would cancel each other. Because that would be the case, there you go. So we now have x by itself on the left side, and 18 minus 6 gives you 12. Now that is the equation. And the subject of our equation is our lovely x over here. So now our equation says x equals 12. Now let's just try to see if that made sense. So we have the equation here, x plus 6 is equal to 18. So question, if I said 12, because we're saying x is equal to 12, so I'm substituting x, which is 12 plus 6, is 12 plus 6 equal to 18? It sure is. And so you recognize that's why we have to, whatever we do to one side, we do to the other. So when we subtracted 6 here, so let me write it. I'm going to draw a bar to go over to the next side. So we have 12 plus 6 subtract 6 must be equal to 18 minus 6. So that x plus 6 will cancel minus 6 because 6 minus 6 would be 0. So we say it's cancelled. So the left side would be equal to 12. And then when we subtract 6 from 18, we also get 12. And so our equation remains balanced. Now, got it? Good. Let's do some other questions. First question, 2x equals to 24. And they want us to make x the subject. Solve for x. Now, please note when we're doing these transpositions, when you want to cancel whatever number is there or whatever expression is there with the variable they want you to make subject, what you have to do is to do whatever operation is there, the opposite. So, for example, we had plus 6. So to get rid of plus 6, we subtract 6. Notice addition and subtraction are opposite to each other. Let me briefly show you that here. So you're seeing the arithmetic operations and their inverse. Inverse means the opposite as well. So if we are having addition, we do subtraction when we want to do the opposite. If we have multiplication, we do division as the opposite. Ones that we sometimes struggle with, if you have a number squared, then the opposite is the square root. Nice. If we have a number raised to any power, and we call that power n, then the opposite would be the nth root. And some persons may not even know that you have bigger than a square root. Yes, you have a cube root, fourth root, fifth root, all of those going up. So naturally, vice versa would apply. So if you have subtract, you would add. Division, you would multiply. Root, you would square. Nth root, you would bring it to the nth power. So let's now apply this to our calculations. So we have 2x equal to 24. So from math, you would learn that once you have a number and a variable with no operation sign between them, then they are being multiplied. So yes, 2x actually means 2 times x. So let me write it like that. It actually means 2 times x. That's equal to 24. Now, if I want to do the opposite, 2 is being multiplied by x. So to cancel 2, I would have to do the opposite, which is divide. And once I do that to the left side, I must also do that to the right side. So now look at it. 2 into itself, 1. 2 into itself, 1. Now we end up having 1 divided by 1 times x, which we know to be equal to x. Then we have 24 divided by 2. 2 into itself, 1. Into 2, 1. Into 4, 2. So we have x is equal to 12. And that's your answer. So x is equal to 12. And let's just do a test. 2 times 12 is of course equal to 24. Excellent. So remember, once you want to make a variable, a letter, or whatever they ask you for, once you want to make it the subject of an equation, you simply have to look at whatever is being done to the other members, and then you would go through and do the opposite operation. Okay? Good. So now just a quick view. When you are separating constants, the same thing I said, but it's written now, so it can be seen and it can stick in our memories. When you're separating constants, which are numbers, from variables, and variables can be letters or symbols, aka making a variable subject. Once you are making a variable subject, then we must perform the opposite arithmetic operation between the two, just as I said earlier. Now it's written there for you to remember. Let's try a second example. So let's look at this one now. It says x squared divided by 2 is equal to 32. Now in this example, you can see that this one is not as straightforward as the first one, but never fear, it can still be calculated just the same. So we are going to look now. So we have x squared. So we have x squared divided by 2 on the left side, and we have 32 on the right side. Now what we want to do is to try to get all the constants, all the numbers, all the things that are preventing us from getting the subject. We get all of we get all of those out of the way at first. So we are being x squared divided, so we have x squared divided by 2. We want to cancel 2. So what we do is to do the opposite. What's the opposite of division? Naturally, multiplication. So let's rewrite. So I'm going to put x squared divided by 2. And remember, to cancel that, we need to do the opposite operation. Multiplied by 2 is equal to 32 And remember, whatever you do to one side must be done to the other, multiplied by 2. Now let's do some cancellation. 2 into itself 1, into itself 1. So then we have x squared times 1 is equal to 32 times 2. And naturally, x squared times 1 divided by 1 is the same as x squared. So we say over here, x squared is equal to 32 times 2, that is 64. Good. So now we still do not have x by itself. It's being squared. What's the opposite of square? Yes, you got it, square root. So I take the square root of the left side, and we must do the same to the right side. Excellent. All right, so now we have it, and guess what? The square will cancel the square root. So we have x now without a square. X is now equal to the square root of 64. And that is equal to 8. And that's your answer. Notice what we did. We first had to get rid of, I would like to call it the constants that are further away from the variable. So we're dividing by 2. First thing we do is to multiply by 2. Get that out of the way. And then now you can focus on the variable itself. So let's just do a quick test. I like to test to make sure that what I've written is correct. So it says x squared and x we're saying is 8. So we're going to do some substitution. Substitution just simply means putting a value in place of a letter. That's what it means. So we are saying x is equal to 8. So instead of writing x here, we're going to put 8. So 8 squared divided by 2 is equal to 32. Let's see if that's right. X squared is 64 divided by 2 is of course equal to 32. And by that we know, yes, our equation is correct. So we know that this answer is correct. Yay! Let's get to a third one. See how well you're doing. And now we're going to get into the physics of it. This is now purely letters, no numbers, and this is something that you will come across oftentimes in physics, the formulas, and you need to transpose them to make a different quantity subject. This formula is for pressure, and the formula is pressure is equal to force divided by area, and they want us to solve for A. In other words, they want us to make a subject. So how are we going to do this? Not an issue. Notice this time, what they want us to make subject is in the denominator. Don't worry about it. It's as easy as 1, 2, 3. So I'm going to rewrite the equation. Now, this time we want to bring the area up to the numerator position. We don't want it as a denominator. We will follow the same procedure. We multiply both sides, this time by A, because we want to cancel it from being denominator here, true? And then whatever we do to the right side, we must do it to the left side. So notice I put my multiplication on the left side. So A into itself and into itself, so we end up having that over there. So now the equation is saying P, which is pressure, times A, which is area, is equal to force. Is the equation done yet? I don't think so. They asked us to make A subject. So now let's look at it. We have P times A is equal to F. We have P being multiplied by A, and we want A all by itself. So what we're going to do this time is to divide by P. And whatever we do it to the one side, we must do it to the other side. And then we have P into itself 1, into itself 1. So now we have 1 times A divided by 1, which we know will be A. So that's A for area. So now we have that area is equal to F for force divided by pressure. Excellent. I hope you were able to get that one. Let's continue. This is another physics question, another physics equation, and this one is for density. Now, the letter here is not a P, it's called a rho, and let me write the name. It's a Greek symbol, Greek letter, and it's called the rho. Now, it's a slanted kind of P looking, but it's not actually a P. So you have to make that distinction. So now they want us to solve for M. Okay, this time the one they want us to solve for is in the numerator. Excellent. Easier stuff. So let's go. Rho is equal to mass over volume. So mass, which is what they want us to solve for, is in the numerator. Volume is in the denominator. We want to get these variables separated. So we're going to multiply both sides by volume because it's in the denominator. Okay, so that cancels that. So now we have mass being equal to density times volume. Yet another one, another equation of physics, and this one is for kinetic energy. Kinetic energy. It's EK for kinetic energy is equal to half mv squared. Let me write it another way. M is for mass, V is for velocity. Is equal to, it could be mv squared over 2. Same thing, same concept. So now we are going to be solving, and they want us to solve for V in this case. Let's get to it. So 2 is in the denominator. We want to get rid of that. So we multiply both sides by 2. Good. So we have, and I'm going to put the constant first, 2ek is equal to mv squared. Wow. Now looking good. Now we need to get v by itself still, and it's being multiplied by m, mass. So we divide both sides by m, because we still want to get v by itself, and we know m to itself will cancel. Let me draw a line to get over here. So we now have on the right side v squared times 1 divided by 1. So we know that's v squared, and I'll put it on the left side. When I'm writing my subject of my formulas, I like to write them on the left side. It's a little neater to work with. And then we have over here now 2 times kinetic energy divided by mass. Are we done? Not quite. We were asked to solve for V, and we have on the left side V squared. What's the opposite of square? Because we want to cancel the square. What's the opposite? Good. Square root. Here we go. Remember, square and square root will cancel, but whatever you do to one side must be done to the other. So velocity, which is what V stands for, is equal to the square root of 2ek divided by m. And now final question. This one is one that you will see in physics, you will see in math. Final question. I've given you a lot of practice, haven't I? Yes. So c squared is equal to a squared plus b squared. Solve for b. Very common question, especially when you have to look at right-angled triangles and finding one of the sides, whether the opposite or the adjacent or even the hypotenuse. This equation comes into play. So now let's transpose and solve for b. So we have c squared is equal to a squared plus b squared. We need to get b squared by itself. It's being added to a squared. So simple thing we'll do is to subtract. Very good. And because b squared is positive, we wouldn't want to subtract b squared because we'll end up with a negative b squared. And then we'll have to do additional steps, which we don't want to do, so we avoid that. So it's going to be c squared minus a squared, because it's being added, which is now going to be equal to b squared. Remember I said I like to keep my subjects on the left, so in my next line I'm going to put it there. So now we have b squared, but they asked us to find b, solve for b. So that simply means we're going to have to square root, because the opposite operation to square is square root. And whatever we do to one side, we must also do to the other. So square root will cancel square. So therefore, and this is a symbol that means therefore in math. So therefore, b would be equal to the square root of c squared minus a squared. And please note, you would not use the square root sign to cancel these squares. Why? Because there is an operation here which is subtraction. So you do not cancel in this case because there are two different expressions. So you leave it as is. You would calculate what c squared is, what a squared is, subtract them, and then after doing all of that, you would find your square root. And guess what? That's it. Yes, congrats, you did it. Yes, excellent, very good. Okay, so now that we've gone through 6 examples of transposition, I hope you are better able to master this concept. Remember, transposition is a balancing act. So whatever you do to one side, you must do to the other. So until next time, thanks for joining.